Rahim. Dr. Mohammad Yusuf from the Department of Chemistry, Islamic College is here. Today, the topic, dear student, which we will discuss is Dalton law of partial pressure. Partial का लघवी माना है जुज़वी, जुज़वी पार्ट से निकला है पार्शल. इस लॉ को डिस्कस करने के लिए जो पॉइंट्स हम बनाएंगे वो है स्टेटमेंट ऑफ द लॉ एंड एक्सप्लेनेशन ऑफ द लॉ. Statement of the law, explanation of the law, and further example, and so on. So here, before coming to the statement, I will try to explain this one, and then I will come toward the statement. Here I have taken three containers. One container contains a gas which I say let it is gas A. The second container contains a gas and let I say the gas is B. The third container contains a gas and let this gas is C. We have taken three containers having gas A, another gas B, and another is having gas C. Now, according to kinetic molecular theory, the molecule of A will collide with the wall of container at a given temperature, and these molecules will exert a certain pressure, and let that pressure is PA. And similarly, the molecule of B are also in motion. Therefore, these molecules will collide with the wall of this container and their pressure is, let's say, PB. Now, if we consider this gas C, its molecule will also be in motion and they will collide with the wall of container and they will give rise to pressure PC. So, three gases are here, A, B, C. All these gases, they are enclosed in separate container. The partial pressure of A in this container is PA, that of B is PB, that of C is PC. These gases are in separate container. Now, let us have this gas B and C, and we enclose them in one container. But keep in mind, the volume of this container should be equal to the volume of the container VA, VB, and VC. It must be equal to the volume of this container. Keep in mind this point. That is, the volume of this container in which we have enclosed all the three gases A, B, and C. They are enclosed in a container and their volume is the same as that of the gas A container, gas B container, and gas C container. So, if this A and B and C, they form a mixture. They form a mixture. In this mixture, the molecule of A will exert the same pressure here as it was exerting in this container. The molecule of B will also exert the same container. The molecule of B will also exert the same pressure in this container as it was exerting in this separate container. And similarly, the molecule of C will also exert the same pressure as in separate container. So here the total pressure of this mixture will be equal to the sum of partial pressure of this gas A in this container, sum of partial pressure of B in this container, and sum of partial pressure of C in this container. And this is what we call as Dalton law of partial pressure, which can be stated that the total pressure, PT means total pressure. The total pressure of a mixture of non-reacting gases. ये बात जो है ये आपने याद रखना है कि A और B और C, it should be non-reacting gases at room temperature. तो A, B और C अगर ये मिक्सचर बना ले और इस कंटेनर का वॉल्यूम जो है वो सेपरेट कंटेनर के वॉल्यूम के बराबर हो, तो फिर यहाँ पर जो टोटल प्रेशर होगा वो A के पार्शियल प्रेशर, B के पार्शियल प्रेशर और C के पार्शियल प्रेशर के मजमूए के बराबर होगा. इस लॉ को हम कहते हैं डाल्टन लॉ ऑफ पार्शियल प्रेशर. लेकिन इसमें एक बात को आपने याद रखना है कि टेम्परेचर here in all these three containers and here in this container, it will be the same. Temperature should be constant. And the second point is the volume should also be constant. As I have told you, the volume of this container must be equal to the volume of this container and must be equal to the volume of this container and the volume of the container in which we have enclosed the mixture. Then the total pressure exerted by all these gases is equal to the sum of partial pressure of A, partial pressure of B, and partial pressure of C. Mathematically, we can say PT is equal to PA, P plus PB plus PC, where this PT is total pressure of the mixture, while PA is the partial pressure of gas A in the mixture, PB is the partial pressure of gas B in the mixture, and PC is the partial pressure of gas C in the mixture. Now a very simple example to illustrate this Dalton law of partial pressure is the pressure of the atmosphere. Atmosphere का जो total pressure है वो 760 mmHg के बराबर है, is equal to 760 mmHg. Now, if we look to the composition of the atmosphere, then the highest percentage is that of nitrogen, which is almost 78%. And this one is 21%, and the rest is carbon dioxide and other gases, trace gases. So the major portion of the total atmospheric pressure, that is 760, and this 760 total pressure, the partial pressure of nitrogen is the highest one, which is 592 mm of Hg. That is the highest pressure in the atmosphere is exerted by nitrogen gas, which make the bulk of the atmosphere, that is 78. And it is then followed by another major gas, that is the oxygen, which is 159. So out of total 760 millimeter of total pressure, 590 is contributed by nitrogen and 159 mm of it is contributed by oxygen, and the rest is very small, is exerted by carbon dioxide and other trace gases. But one point which we should keep in mind, where this Dalton law of partial pressure will be applicable, means if you have this mixture A, B, C, what should be the nature of this these gases so that we can apply Dalton law of partial pressure. So keep in mind it is applicable only and only to a mixture of non-reacting gases. Mixture of non-reacting gases. And it is not applicable to a mixture of reacting gases. So here I have taken some example from non-reacting gases, carbon dioxide and oxygen. It is a pair of non-reacting gases. So it is applicable to this one. If you enclose carbon dioxide and oxygen in a container at room temperature, then the pressure of carbon dioxide and the pressure of oxygen will be partial pressure, and the total pressure will be the sum of carbon dioxide and that of oxygen. That is the pressure exerted by oxygen and pressure exerted by carbon dioxide. Similarly, at room temperature, carbon dioxide is unreactive with nitrogen. Carbon dioxide is unreactive toward chlorine. So it is applicable to these pair of gases. But if you take reacting gases like carbon monoxide and chlorine, it is not applicable. If you take methane and chlorine at room temperature, it is not applicable. If you take ammonia and HCl, it is not applicable. So one point which you should keep in mind, the Dalton law of partial pressure is applicable only to a mixture of non-reacting gases. These are the example of non-reacting gases. Here we have reacting gases, so Dalton law of partial pressure cannot be applied to these pairs. Now, if you are given a mixture, let's suppose you are having a mixture, mixture of gases A, B, and C, and you are asked that what is the partial pressure of A in the mixture, what is the partial pressure of B in the mixture, and what is the partial pressure of C in the mixture. ये आपसे क्वेश्चन कर लेते हैं, क्वेश्चन के आपको मिक्सचर दिया गया है ए बी सी और इनमें आपसे पूछते हैं कि व्हाट इज द पार्शियल प्रेशर ऑफ ए, व्हाट इज द पार्शियल प्रेशर ऑफ बी, व्हाट इज द पार्शियल प्रेशर ऑफ सी. इसके लिए फार्मूला जो है, फार्मूला वो है PG. PG is the partial pressure of the PP means partial pressure of the component gas. Component gas. Component gas means either A, B or C. Mg is the number of mole of the gas. Number of moles of the component gas, of the gas. Nt is the total mole of the mixture. Total mole of the mixture. And Pt is the total pressure of the mixture. So, in the question, what will be given? You will be given the number or mass of the gas. Remember, the number of moles of the gas or mass of the gas. If the number of the mole of the gases are given, then it is easy. But if mass is given, you have to convert the mass of the gas into moles. And you know how to convert the mass of the gas into moles. That is mass n gram divided by molar mass. So Mg is the number of mole of the gas. Nt is the total mole of the mixture. Pt is the total pressure of the mixture. So then put the total number of moles here, the number of moles of the given gas here, and the total pressure here. You can easily calculate the partial pressure of the gas in a given mixture. Now let's have an example on this in order to clarify it further.
Start.
In order to clarify this equation, let's have an example. Here we have a mixture of helium and hydrogen, which are non-reacting gases. We have taken 2 gram of helium and 2 gram of hydrogen in this container. Now, as I have told you before, that if you are given mass, you have to convert it into moles. So, number of mole of helium will be equal to mass in gram, that is 2 divided by 4, and that is equal to 0.5 mole. Remember, first of all, you have to convert mass into mole. So, the number of mole of helium from 2 gram is 0.5 mole. Similarly, NH2, number of mole of hydrogen, 2 by 2 is equal to 1 mole. Now the question is pretty easy. There is no problem. You have number of moles of helium, you have number of mole of hydrogen. So from this, total mole is very easy. Total mole is very easy. How? Number of mole of helium 0.5 and number of mole of hydrogen is 1. So total mole is 1.5. Now you are having this one, you are having total pressure, you are having number of mole of helium, you are having number of mole of hydrogen. Just use this formula. How? For example, I want to use this formula for helium. What I should do? Instead of Pg, I will write Phe. Instead of Nt, I will write 1.5 here, 1.5. Just put the value of Nt here, 1.5. Ng, number of mole of the gas. Number of the mole of the gas means here helium, it is 0.5. Multiplied by total pressure. The total pressure is 1.5. Here it is given. So again, pressure of the gas, pressure of the helium here, number of mole of the gas, number of mole of helium here, total mole here, and total pressure here. So calculate it, you will get 0.58 here. Similarly, for hydrogen, partial pressure of hydrogen 1.5, and here put 1 and 1.5, 1.8 here. इसका मतलब ये हो गया कि यहाँ पर number of mole of helium is half as compared to the number of mole of hydrogen. Therefore, the number of molecules of helium will be half than the molecules of hydrogen. That's why hydrogen will exert twice pressure and helium will exert half of the pressure exerted by hydrogen. From this conclusion, from this example, we can conclude that the pressure of a gas is directly proportional to the number of mole of the gas. Means जितने number of mole ज़्यादा होंगे mixture के अंदर, जिस तरह हाइड्रोजन है, number of mole ज़्यादा होंगे तो pressure ज़्यादा होगा, number of mole कम होंगे तो pressure कम होगा. So thank you very much for listening to me. This is the end of Dalton law of partial pressure.